Hello everyone, welcome to VLSI Design Lecture Series. In this session, we are going to discuss about twin well or twin tap CMOS fabrication process. So here is the question: why do modern CMOS technologies use both P-type and N-type wells on the wafer surface? Here today we are going to explore twin tap CMOS fabrication process, the most flexible and widely used CMOS technology. So here, what is mean by twin tap? It's a combination of P well and N well. Okay, so that's the reason we are calling it as twin tap. Okay, and now here we'll be first how we'll be starting the process here is, and before that, and this twin well, right? It is how it's of we can partially control N will and P will. It will partially control both, and this twin tap is independent optimization of PMOS and NMOS and PMOS. The twin tap process allows separate control of threshold voltage, body effect, and performance of both transistors. So here is your first step. First is we'll be selecting a material. First, we'll select a lightly doped epitaxial silicon layer, and we'll be growing a heavily doped substrate there, and it provides low noise and latch-up immunity. It has latch-up immunity. So here in twin tap, it uses both P well and N well. Next one will be having a growth epitaxial layer growth, a thin epitaxial layer grown on the substrate so that it improves device oscillation, latch-up prevention, and uniform doping. Okay, your next one is will be growing a SiO2 layer. Okay, by oxidation, we'll be growing a SiO2 layer as a masking layer. And next one is your photolithography, right? In photolithography, it involves three process. First one is coating it with photoresist layer, and next one is we'll be having a mask and expose it to UV rays, and it so that it will be easy for us to remove. And by etching, we'll be removing. So this is a process involved in photolithography. So after oxidation, you'll be having a photolithography so that we can form a well. Okay. So here you can just see we have added a mask and we have exposed to UV rays so that we can form we can remove the unwanted layer. So if we have removed here, okay, we have removed here, and by diffusion you have formed a N well. Okay, so N well and P well are formed by diffusion. Here N well will be having a phosphorus or arsenic implantation, and separate masks are used, and high temperature is used here, and NMOS are done by fabricated in P well, and PMOS are fabricated in N well. Okay, and we have diffused N well here, and we have diffused P well here. Again, we have coated with the thin SiO2 layer. Okay, and again by CVD process, that is chemical wafer deposition process, we have coated with a polysilicon layer. After that, this is a polysilicon layer. After that, we have again done photolithography. Okay, we have removed the unwanted layer, and now we are diffusing N plus and P plus layers here. Okay, we have diffused, that is for your source and drain. Okay, gate formation again. Okay, and if for NMOS in P well, N plus is diffused for source and drain, and in PMOS, that is in N well, P plus is diffused for source and drain, and your last step is metallization and interconnects. Okay, so here what we are doing here is contact windows are open, aluminum copper deposited, and interconnections are patterned. That is where we'll and that is your in which position you have to connect the input and which position you have to connect the output. So that is done here. So it's a common as you can see here. So this is your VR, VN, this is your Vout, this is your source and drain. So likewise you can make it. So that's all with the twin well fabrication process. Thank you.